tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Melati kuntum tumbuh melata, sayang merbah di pohon cemara. Assalamualaikum, ulangnya kata, salam sejahtera untuk semua. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat datang ke kelas tuisyen percuma yang dibawakan khas untuk anda oleh Akademi Youtuber Malaysia dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Apa khabar anak-anak pelajar di luar sana di mana jua anda berada? Cikgu doakan anda sentiasa berada dalam keadaan yang sihat dan sejahtera. Jadi siapa yang bersama dengan kita pada malam ini? Anda boleh kenalkan diri pada live chat, siapa nama, dari sekolah mana. Okey, jadi malam ini cikgu akan sambung dengan kelas tingkatan 5 iaitu kelas untuk DLP. Tajuk dia 3.1 3.1 Current and Potential Different. Okey, jadi dengan tidak membuang masa lagi sebelum kita mulakan kelas, ayo kita mulakan dengan Ummul Kitab Al-Fatihah. Kepada yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Kita tengok ada di sana, kita ada Rashid. Waalaikumsalam Rashid. Ya, selamat menunaikan solat Isyak. Terima kasih sentiasa menyokong cikgu saban minggu. Dan kita juga ada Cia Yau di sana. Apa khabar Cia Yau? Terima kasih juga sudi support tim fizik dari dulu hingga kini. Alhamdulillah. Jadi tanpa melengahkan masa, cikgu kongsikan slide cikgu pada minggu ini. Sebelum itu untuk anak-anak semua, cikgu ada kongsikan pautan latihan PDF kopi yang cikgu akan bincangkan pada malam ini. Anda bolehlah muat turun dan cetak keluar secara percuma saja. You can download all the PDF copy and print them out all for free. Jadi itulah istimewanya Akademi Youtuber. Bermula percuma, selamanya percuma. Yes, thank you for supporting me, Cia Yau. Okey, jadi cikgu mulakan. Sebelum itu, ini adalah jadual kelas kita pada minggu ini. Telah berlangsung pada Jumaat yang lepas, kelas fizik untuk tingkatan 4 dengan tajuk yang terakhir untuk bab 2 iaitu berat 2.8 telah disampaikan oleh Cikgu Izyan. Jadi sesiapa yang telah terlepas kelas itu, anda jangan risau, tonton saja ulangannya di channel Cikgu Izyan. Okey, jadi pada malam ini cikgu teruskan dengan subjek tingkatan 5 iaitu as you can see there, the title is topic is 3.1 Current and Potential Difference. Alright. Okay, nanti cikgu kongsikan link studio Ciayo sebentar lagi. Alright. So ini adalah barisan guru-guru panitia fizik di SPM, di Akademi Youtuber yang telah banyak membantu cikgu terbitkan video PDPC sama ada dalam bahasa Melayu ataupun bahasa Inggeris. I have my student there. Okay, hello Wen Hui. Thank you for joining us tonight. Alright, I hope this session will benefit you with 3.1 electric and potential difference. Okay. Dan kalau anda belum lagi muat turun apps ini di Android anda boleh muat turun sekarang. Appsnya Akademi Youtuber, cari saja di Google Play Store. Apa yang ada di dalam ini, kita ada lebih daripada setakat ini kita ada lebih daripada 25,000 video PDPC yang telah diterbitkan oleh guru-guru AYU dari seluruh Malaysia untuk subjek bermula daripada prasekolah hinggalah ke pra-universiti. Jadi gunakan sebaik mungkin alat bantu mengajar yang ada. Mudah-mudahan membantu anda menguasai tajuk-tajuk dengan lebih baik. Alright. Okay students, so this will be our topics tonight. So again, it is chapter 3, electricity. The first, content standard 3.1, current and potential difference. So if you are ready, can you type at the live chat there, ready teacher, sedia cikgu. So we have 3.1, current and potential, and 99 from page 92 until page 99. So you can refer to your textbook as well while following this lesson. Okay. We also have Jiachi there and Putri Alia. Hi, thank you for joining us and welcome to our physics online classes brought to you by Akademi Youtuber. Okay, students. So this will be our topics tonight. They are all 5 learning standards which you must know and master very well. So the first one is to explain electric field. So what is electric field? Later we are going to see them. Followed by how to define strength of electric field through formula. And also we will explain the behavior of charged particle in an electric field. Later we will have 2 example of situation how to explain the behavior of this charged particle. And next is to define electric current. So what is electric current? So I believe you have learned in school, so you can share all your thoughts in the live chat as well. And last but not least is to discuss about potential different. Okay, so Chiaya is ready. I think everyone also ready. So without further ado, let us continue with our discussion with the first learning standard to explain electric field. All right. So as I mentioned before, you can have your PDF slide copy for this lesson. It was there in the pin messages. Okay, so you can download and print them out for free. All right. Okay, so this is the first learning standard. What is electric field? All right. Okay, so let us take a look at this short demonstration. And what is electric field?
Shake your head no. You are really mad. Tell them no.
Okay, can you see what happened to the girl's hair there? Anyone can share with us what happened to the girl's hair? What happened to her hair? Why it stand up like that?
There you go.
When he touched that circle thing, we call it as a Van de Graaff generator.
You see yourself in the mirror. Oh wow! Now don't touch your hair, sweetheart. What do you say?
Okay, anybody has tried this activity at school? I believe you have conducted them with your teacher. So this is one of the apparatus we can use in the laboratory to study about electric field. Okay, students, so if you check from your textbook, okay, so this is how electric field exists around us. So believe it or not, we are surrounded by electric field. Okay, I believe if you used to go to the supermarket, when you touch the trolley, sometimes you can feel the electric shock. Okay, am I right? When you push the trolley, so that is shows electric field is around us. So this is some example taken from your textbook, which shows the existence of electric field in our daily life. Okay, the first example there, actually you can try all these at home. You just take a comb, then rub it with your hand or with a material, any fabric, and then you bring it close to a water stream from the tip. So you will find out the water will be bent when a charged comb is brought near to it. And second, you can see this girl, her hair is attracted to a charged balloon, showing that electric field is existed in between the balloon and her hair. And the third example, they again a charged comb when bring into a piece of paper, so it will attract the paper onto it, again showing that electric field is exist. And last example there, when you place a charged drinking straw on top of a bottle and you try to approach it with a finger, you will see it shows a ocean. So these few examples shows to us electric field are there around us. All right. Yeah, touch electric. Okay, so that is what say by Chia Yao. So I would like to invite those who able to come to the studio to join me here in this Conti. So I share the studio link to you now. So if your camera and microphone are all in good, you can click the invitation link and join me here at this studio. All right. Okay, students. So let us continue with the next activity. So what is electric field? Anyone, what is meant by electric field? So electric field is the region, the area, okay, where charge experience an electric force. I repeat, electric field is a region or an area where an electric charge experience an electric force. Okay, so for example, okay, this is the two charges, okay, two unlike charges which is placed next to another. So you can see a line there showing that electric field exists in between them. All right. Okay, so this is one study conducted at the school laboratory in order to study electric field by using an electric field kit. All right. Okay. So these are the connection, all the apparatus and material needed. Okay, we need an extra high tension. Extra high tension is a high voltage power supply. Okay, we also require some oil, olive oil and semolina powder to represent the charges. Semolina powder represent the charges. Okay, hello Chia Yao. Thank you for joining our Conti. Chia Yao
Hello,
sihat ke?
hello,
Ya.
cikgu. Hai,
Ya,
cikgu.
hello. Okay, sihat eh? Alright. Okay. So I show you some short demonstration.
Rakan guru sekalian, sini saya nak tunjukkan corak medan elektrik menggunakan set seperti ini. So untuk set ini saya perlukan power supply high voltage, kemudian minyak masak. Kita tuangkan minyak masak.
Okay.
Jangan terlalu banyak, sedikit pun tak sesuai.
So this is one example of demonstration conducted by one teacher. Credit to Cikgu Suryati from Mosaic. Actually, I took this video from the slide she shared in the physics telegram group. Okay. So earlier we put an olive oil into these petri dishes, and then we connected the positive and terminal plate to the EHT, and then we sprinkle some semolina powder to represent the charges. So later you will see the semolina powder will form a pattern. Dia akan membentuk satu pattern menunjukkan wujudnya medan elektrik di antara dua plate, to shows the existence of electric field in between these two rod or metal plate.
Lihat.
Okay.
Ada perakan. Okey, kita naikkan voltage. Kita nampak ada bijian yang bergerak ke terminal positif.
Okay, so you can see that the moment the teacher switch on the EHT power supply, so the semolina powder started to move and shows a pattern. So it shows that there is an electric force existence in between those charges, which form an electric field. All right. Okay, so students, this is the observation we can gain from these activities. Okay, so I want you to try to draw the electric field pattern for each of these 6 examples. All right. So for the first diagram, when there is a road which is connected to a positive terminal supply. So this will be the pattern of the electric field. Ini bentuk medan elektrik dia. So if the plate is positive, so you will see the direction of the electric field will be outwards. Dia mengarah ke arah luar. Okay. And for the second diagram, now we connect a single road to a negative power supply or negative terminal of the power supply. And you can see this will be the pattern. Okay, the direction will be inward. So simple. Positive will be directed outwards, while negative will be directed inwards. Kalau positif, arah dia keluar. Ciayau kalau kamu lukis. Kalau charge dia negatif, arah dia ke dalam. Alright? Okay. Okay, now for the third example, now we have 2 plates. Okay, 2 parallel plates, positive and negative plates. So this will be the directions of electric field from positive into negative. So you can see the direction of the arrow is from positive to the negative terminal. Okay, and then on the fourth diagram, we have a parallel plate connected to negative terminal and positive road there. So again, the directions of electric field is from positive to negative terminal. So very simple. The directions of the electric field lines always from positive towards the negative charge. All right, or negative terminal. Okay, now if you look at the fifth diagram, okay, now we have 2 electrodes. On the left connected to the negative terminal and on the right connected to the positive terminal. Again, so this is how we draw the electric field pattern. Okay, again at the center from the positive directed to the negative terminal, and here at this side it was inwards. Okay, inwards to the negative, and on the right side it moved outwards from the positive terminal. All right. Okay. Okay, try F. Try to draw F. Now we have both negative, both connected to negative terminal. So what will be the pattern of electric field be like? Okay, so it will be like this. Okay, so at the center, since it is like charges, so it will be directed inwards. Okay, so we will have a blank spaces there at the center. Okay, so at the side it will be inwards, and on the right side also will be moving inwards. So this is the example of pattern of electric field based on what type of terminal we are using and which terminal we are connected them to. So what you can study here, electric field pattern always directed from positive towards negative terminal. All right. So this is a few example of question you may ask when we conducted this activity. Why we must use EHT power supply? Why must use high voltage power supply in this study? Kenapa nak gunakan bekalan voltan yang tinggi dalam eksperimen ini? So it is to provide a strong electric field. Alright. And then second, if you look at the parallel plates, what happened to the plates when EHT is switched on? So the 2 electrode will be at different potential. Okay. Where one connected to a positive terminal, another one connected to a negative terminal. So this will create a potential difference. So due to this, an electric field will exist between those 2 electrodes. And the third question, why does the sprinkled semolina powder form a certain pattern? Okay, as I mentioned, this semolina powder, it represents the charges because we can't see charges because they are too small in size. So we represent charges by semolina powder. So once we on the EHT, it will experience an electric force. So they will form a pattern. Okay. And number 4, why we are using cooking oil instead of water? Can you imagine what happened there if we are using water? Apa jadi kalau kita letak air tadi dalam bekas cuci ayam? What do you think will happen? Nanti kena electric shock. Okay, because water is a good electrical conductor. So that's why we are using cooking oil, because it is not an electrolyte. All right. So the next question. Why is metal plate used? Why not using a wood or stick, rubber or plastic? So this is a very simple question, because metal is a good electrical conductor. All right. So number 6, the pattern shown by the semolina powder. Okay, you will see it will form a line, a pattern of line. So this line actually represent the electric field line. Okay, and when they are closer to one and another, it shows that the electric field is stronger. Okay, and when these lines are further from one and another, meaning that the electric field is weaker. All right, and the last question there. The electric field of force never cross over. So students, when you draw the electric field line, make sure they are always parallel. Okay, they never cross one and another. Okay, and the direction is from positive towards negative charges, or from positive towards negative terminals. Okay, so that is to do with the first learning standard. To define what is electric field. So what is electric field? Can you repeat after me? Yes, very good. So electric field is the region where electric charge experience an electric force. Okay, now let us continue with the second learning standard to define strength of electric field. Alright, so how to know either the field, electric field is stronger or weaker? So if you look at this screen, so you can see there is a positive charges and negative charges placed there. Okay, so you can assume that a positive test charge Q is placed in an electric. So let's say we place a positive test charge Q here. Okay, in an electric field. So first we place it. So you will feel that this test charge will experience a repulsive force. Okay, since the charges are same. So remember, like charges, they repel each other. So it will experience a repulsive force. While for this one, when we place a positive test charge to a negative charges, so it will experience an attractive force. So we understand here, unlike charges are attracted. Okay, attractive forces exists in between unlike charges, and repulsive force exists in between like charges. Okay, so this is the definition of electric field strength. Okay, so what is electric field strength? It is defined as the electric force acting on a unit of positive charge placed at a point. I repeat, what is electric field strength? It is the electric force acting on. Electric force represented by F. Okay, electric force acting on a unit of positive charge represented by Q from this equation, where electric field strength represented by E. So this is the equation. E equal F divide Q. Okay, so what is the unit for electric field strength? The unit is Newton per coulomb. Newton is for force and coulomb is for charge. So the unit is Newton per coulomb. All right. Okay, next student. Okay, if you look at this diagram, it shows two parallel plates connected to positive terminal and negative terminal to EHT power supply. So this will create a potential difference between these two, where when I switch on this EHT, so electric field will be exists in between them. So this is the line showing electric field line exists between these two plates. All right, so you can see that they are uniform and the distance is uniform from one and another. Okay, so we understand uniform electric field is represented by a set of this parallel electric field line. Okay, so from here we also can determine electric field strength. Okay, by this formula, electric field strength by this diagram is the potential difference divide. Okay, potential difference supply by the EHT or the voltage supply between these two parallel plates divide with the distance. Okay, so what happen if I increase the distance between these two plates? Okay, when I maintain the voltage but I increase the distance, so we'll see that the electric field strength will become weaker. Okay, but when I bring these two plates closer to one and another, mean the distance is shorter. So what happened? The electric field strength will be greater. Then, all right. Okay. So the unit for electric field strength according to this formula is volt per meter. Okay, volt per meter. So there are two equations you can determine strength of electric field, where the first one is E equal to F divide Q, and second is E equal V divide D. All right. Okay. Now let us go for behavior of charged particle in an electric field. Okay. Cik Ayah okay ke? Okay eh? Right. Later, then we will replace the ping pong ball with candle. Okay, so we will see the effect of the plate. Yeah, yeah. What is it?
Cikgu tak dengar, suara rendah.
Tak dengar? Suara slow eh? Okay. Sekarang dengar ke? Okay, boleh dengar?
Boleh.
Okay, good. Okay, so this is the step provided. So you can read them from number 1 until number 5. Okay, so when we switch on the power supply and displays the polystyrene ball, so it touch one of the metal plate. So and record your observation. Okay, so then we repeat the step by decreasing the distance between the two metal plate, and then second, increase the voltage of the EHT. So actually this experiment, we want to study the two factors affect the electric field. The first one is a distance between the two metal plate, and the second factor is the magnitude of the voltage supply. All right. Okay. So this will be the observation. Ini pemerhatian yang anda boleh dapati. Okay, so for this diagram of apparatus, so initially we place the ball in between of the two metal plates. Okay, initially we started by placing the ball in between of the two metal plates. So what will happen to the ball when the EHT power supply is switched on? So at this moment, when the ball is at the center, it will not show any movement. Okay, it will keep stationary. Student, at that moment, it will keep stationary. And these are the two forces acting on the ball now. Okay, so these are the two forces acting on the ball now. Okay, so there are two forces attracted the ball each to the metal plate P connected to the positive terminal, and metal plate Q connected to the negative terminal. Okay, the magnitude is equal but opposite directions, which mean the forces acting on the ball now is equilibrium. So that's why the ball is now remain at the center. Okay, so it is now neutral. So it does not move either to the left or either to the left. It remained at the center. All right. Okay, we also have Jimmy there. Okay, welcome Jimmy. Thank you for joining our physics lesson tonight. And don't forget to get your PDF slide copy at the pin messages there, right? Okay, so what happened there, students? So as you can see, when we switch on the EHT, plate P will be positively charged, while plate Q will be negatively charged, as you can see here, the connection. And since the ping pong ball is neutral, so it remained at the center as the electric forces acting on it are equal but in opposite direction. So the electric force here refers to the attractive force from both metal plate P and metal plate Q. All right. Okay. We also have Cashwin there. Okay. Hi. How are you doing? Where are you from? Okay. Thank you for being here in our lesson. All right. Okay, now students, so this is how to explain, okay, what happened to the ping pong ball. Okay, now, what happened if we displace the ping pong ball to one of the plate? So if you look here, when we displace the ping pong ball now to the negative plate, so what will happen to the ball? So you will see that when we displace the ball to the negative charge metal plate, so the positive charges of the ball will be discharged. Okay, so all the positive charges on the ball will be discharged by this negatively metal plate. So what happened to the ball? It will remain with the negatively charged. So now the ball is negatively charged. So now we have negative, negative. And negative, negative. So what happened? Repulsive force will be acted upon them. So it will push the ball to the other side. All right. So are you clear with that? Okay. So now the ball will be pushed to the positive plate terminal. All right. Okay. We also have Jin Hang there. All right. Thank you, everyone, for joining our lesson tonight. Okay. Now, next diagram. Okay, so what happened to the ball when now it reached the positive terminal? So at the positive terminal of the metal plate, what happened? The electron in the polystyrene ball will be transferred to the metal plate. Okay, electron transfer or attracted to the positive metal plate. So what happened? The ball is now become positively charged. Okay, it become positively charged. So now we have positive charges, like charges. Again, what happened to them? Yes, very good. Repulsive force acted. So repulsive force will push the ball away to the opposite side. So this process will occur repeatedly, student. Until when? Until we switch on the EHT power supply. Okay, so you can read again for further understanding how the ball keep oscillating in between the positive and negative metal plate. Okay. Okay, so this is another video shows to you the demonstration. So you can see that the ping pong ball is keep oscillating in between the two plates. Okay, similar to what I explained to you just now. Have you tried this activity at school with your teacher? If you have, can you give some response to the live chat? Yes, we have conducted this, teacher. And it is so excited. Okay. Okay, next. Okay, then. Okay, so students, can we try to answer these three questions? Okay. Just now you see the ball is oscillating in between two plates, right? So how can we increase the speed of the ball? Okay.
Negative.
So there are three factors that affected.
No one.
Okay, Ciaya, macam mana nak bagi dia laju? The distance between the two metal plate must be further or must be closer? Increase or decrease? If you want to increase the speed of the oscillating ball, so what need we do with the distance between the two metal plates? Must we bring them closer or further to one and another? So what to write here? Distance between the two
Negative.
metal plates is decrease or increase? Decrease or increase? So we have to
Decrease.
decrease. Yeah, we have to decrease the distance. Then the ball will oscillate at higher speed. Okay, second, the mass of the ball. Okay, how? If we want to increase the speed of the ball, so what happened to the mass? Must we increase the size or
Negative.
reduce? Using bigger ball or using smaller ball? Bigger mass or smaller mass? So what is the relation between mass and speed? You can relate mass
Smaller.
and force. So we are using
Some-
smaller. The mass of the ball must be smaller. You remember when the mass is smaller, the acceleration is higher from F equal to ma. Okay, so acceleration here can be related to speed as well. So when the mass is smaller, the speed of the ball will be higher or greater. And third, the voltage of the power supply. So definitely we must use, yes, a high voltage
Negative.
power supply. So we say the voltage of the power supply must be increased. So remember, if you want to
Increase.
increase the speed of oscillating ball, first we decrease the distance between the two plates, use smaller mass ball of smaller mass, and then third, to increase the voltage of the power supply. All right. Okay, next. Okay, since many of you joining us tonight, so I would like to remind you again, I have shared to you the link for PDF slide copy for this lesson. You can download and print them out for free. All right. So I hope it will help you to understand this topic in a better way. Okay, now student, let us replace the ping pong ball with a candle flame. What will happen then to the candle flame? So there, this is the apparatus. We use the same setup, only we change the bowl with candle flame. So when you switch on the EHD power supply, later on you will see that the candle flame will spread into two portion. Dia punya api tu akan bahagi kepada dua, will spread into two portion. Some portion attracted to the positive plate, and there is a portion attracted to the negative. And you will find out the spread is not symmetrical. So why they are not symmetrical, we will explain that later in this next slide. Okay, so you will see that
Bigger.
the spread of flame towards the negative plate will be bigger. All right. Actually, I have one video there, but just now it's not working. Okay, so first we can complete this diagram. All right, can you
Positive,
write
negative.
the charges for X and Y? Yes. So X, see, connected to the positive terminal of power supply.
Positive.
Yes.
Pass.
And Y, yeah, Y will be negative charges since it is connected to the negative terminal of the power supply. Okay, next. Draw the shape of candle flame when it is placed in an electric field. So you can draw. So this will be how the flame spread into. So you can see bigger portion spread to the negative terminal and small portion spread to the positive terminal. So they are not symmetrical. And why is that so? Kenapa dia tak sama? Okay, so it will be explained here. Smaller decrease. Yeah. Thank you for your response, Jimmy. So I believe this is the previous question. The three-factor effect, the speed of ball oscillating in between two plates. All right. Okay. So student, this will be the effect on the candle flame. So what is the effect of the candle flame on the A around the candle? So once we light up the candle flame, so what is actually the flame do to the A around it? Okay, I repeat, what will the flame do once we light it up? So it will, yes, it will ionize the A molecule around it into positive and negative ion. Once we light up the candle flame, it will start to ionize the A molecule around it into positive and negative ions. All right? Okay.
Negative.
Okay, so why the shape of the candle flame is like this. So can you complete the blank spaces here? So the positive ion attracted to negative plates. The one, the negative ions attracted to the positive plate. And why they are not symmetrical? This is the reason. Because positive ion has larger mass and size. You also learn in chemistry, okay? The size of proton and electron. Proton is positive ion and electron is negative. You have learned their size in chemistry, and I believe you know very well the comparison between the mass of those two charges. So positive ion has larger mass and size. So with the same number, so therefore, the spread of flame towards the negatively charged metal plate will be greater. So if we have 10 positive charges here and 10 negative charges, still the portion spread to the negative plate will be bigger because of the mass and size of positive charges are greater compared to the mass and size of negative charges. So this is the reason why the flame spread in not asymmetrical portion. Okay, are you clear with the explanation, students? So this is actually a frequently asked question. Okay, explain why the candle flame is not symmetrical. So now you know the reason, because positive ion has a larger mass and size. So this will cause more portion of flame spread to the negative terminal compared to the positive terminal. Alright? Okay, I think let us take some short breaks. So don't go away. We will continue with another two learning standard and some example of exercises. We will be back soon after this. Okay, student, welcome back to our physics class for SPM. This is 3.1, electric current and potential difference. You are now with me, Cikgu Hasnitah from SMK Baganjaya, Butterworth, Pulau Pinang. And we have our friend there in the studio, Eng Chia Yao. Hey, Chia, say hi to them. Okay, so let us now continue with 3.1.4 to define electric current. Okay, so I hope you are doing well so far with this lesson. So what is electric current, student? Apa itu arus? Kalau yang belajar dalam bahasa Melayu. So what is electric current? So if you look at this diagram, so I took this diagram from your textbook. Okay, so electric current is actually defined as rate of flow of charge. Again, what is electric current? It is rate of flow of charge. So you can see now there is a red dot there. So this red dot represents a charge. So there is a charge flowing across a conductor there. So how much charge flow in 1 second? So we call them as a current. So rate of flow of charge. And this will be the equation. Okay, current I is Q charge divide time. Remember when we talk about rate, which means we are dealing with time. So the formula is I equal Q divide T, where I is the current, Q is the amount of charge flow, and T is the time. So again, what is current? Rate of flow of charge. And the SI unit for current is coulomb per second. Coulomb is the unit for charge and second is the unit for time. Or normally we write them in terms of ampere. Okay, coulomb per second or ampere, capital A, ampere. Alright, so what is 1 ampere current means? Anyone? What is meant by 1 ampere current? So 1 ampere current means there is 1 coulomb of charge flow across a conductor for every 1 second. Okay. Then what is the meaning of 50 ampere? 50 ampere. So what is 50 ampere? 50 ampere of current means there are 50 coulomb of charge flow across the conductor for every 1 second. What about 1000 ampere of current? So what is 1000 ampere of current refers to? It means 1000, we have 1000 coulomb of charge passing through a conductor in 1 second. So I hope you are clear what is current. It is rate of flow of charge. It tells how much charge flow across a conductor for every 1 second. Okay, so this is the diagram shows how charges flow in a circuit which finally produces current. So if you look at these notes, current flow because charge or electron flows. So direction of current opposite to the direction of flow of charges. Current flow from positive terminal to the negative terminal. Before that, if you look at the charges here, this is the direction of flow of charges from negative to positive terminal. So once the movement is complete, then only current flow at the opposite direction from the positive to the negative terminal. Okay, so that's all to do with 3.1.4. What is electric current? Again, it is rate of flow of charge. So actually, this is 3.1.5. Okay, I'm sorry for the wrong typing there. This is the final learning standard for tonight. 3.1.5. What is potential difference? Okay, so you understand what is electric current. Now, let's understand potential difference. Okay, so this is the question you can ask yourself to understand potential difference. What causes charges to flow, student? What causes charges to flow? All right. So what causes charges to flow? Any answer or any idea? Jimmy, maybe we have Kai Chong Chan there. We also have Yu Yongzhe. I hope you're still with us. Jin Hang. We also have Kershwin earlier. And also Putri Alia, Jiachi Wenhui, and Rashid. Okay. So what causes charges to flow? Anyone? How charges able to flow from one point to another in a circuit? So this is because the existence of potential difference. Okay, so current can flow from one point to another due to potential difference between the 2 points in a circuit. So if you look at this simple circuit, there are 2 points there in between this about point A and point B. All right, point A and point B. So this defines as potential difference. So what is potential difference? Potential difference is the work done. Okay, work done or energy transferred in moving 1 coulomb of charge from one point to another. So in order to move charges across these 2 points, so it need energy. So where does the energy coming from? The energy comes from the potential difference of the power supply or the battery if we place a battery here. So the battery or the power supply energy to the charger so they can move across these 2 points from A to B. So I repeat what is meant by potential difference. It is the work done or energy transfer in order to move 1 coulomb of charge from one point to another across a conductor or around an electric field. And this is the formula for potential difference. Potential difference also known as voltage. Okay, so voltage is work done. Okay, work done in order to move 1 coulomb of charge Q from one point to another. Or you can also write V in terms of E divide Q. E is the energy transfer. Okay, potential difference is energy transfer to 1 coulomb of charge from one point to another. And the unit for potential difference is joule per coulomb. Joule is the unit for work or energy, and coulomb is the unit for charge. Or normally we write in volt. Okay, the unit for voltage is joule per coulomb or volt, capital V. All right. Okay. So now What is meant by 1 volt? So from this equation, we understand 1 volt means the work done to move 1 coulomb of charge from one point to another is 1 joule. Mean we need 1 joule of energy in order to move 1 coulomb of charge from one point to another across a conductor. So if they give you another value, 100 volt. So what does 100 volt mean? What does 100 volt mean? It means 100 joule of energy. 100 joule of work is done in order to move 1 coulomb of charge from one point to another across a conductor or in an electric. Let's try some of these exercises. Okay, let us test your we are now let's work with question 2, student. We have a metal wire as our conductor. The charges are carried by electron. Okay. So what is electron? Electron is a charge carrier, negative charge carrier. So each electron carries a charge of 1.6 times 10 power of 19 coulomb. So every single electron, they carry 1.6 times 10 negative 19 coulomb of charge. So can you find how many electrons in 1 coulomb of charge? Okay. So how to relate this? So this is the formula, relate charges and number of electron. Okay. So this is the formula, Q equal 1E. So we have 1 coulomb of charge there. So Q is 1. So we are looking for N, number of electrons. And E is a charge for 1 electron. This is a fixed number, student. 1.6 times 10 negative 19. Okay, so you just do the substitution as shown here. So we'll find this is the number of electrons in 1 coulomb of charge. 6.25 times 10 power of 18. Alright? Okay, students. Okay, next. Question 3. Okay, let us do together. Again, this question relate to current. Current flow in a bulb is 0.5 ampere. Okay, so you can highlight I equals 0.5 ampere. So first, calculate the charge flow through a light bulb in 2 hours. Okay, so find the charge flow through a light bulb in 2 hours. So we have 2 information there. First, we have current 0.5 ampere, and then we have the time 2 hours. So we are looking for charge. Charge is Q. So how we relate Q, I, and T? Anyone? How we relate charge, current, and time? Remember what is current is rate of flow of charge. So I equal to Q divide T, which means if you rearrange the formula, so charge is equal to current multiply time. Okay. Ada calculator tak Cik Ayah? Boleh kira bersama. You can check either my answer is correct or not. So current 0.5 given there. So the time you have to be careful since it is given in hours, so you have to convert into second. So 2 hours is 2 times 60, convert into minute, and then times another 60 to convert the answer is 3,600 coulomb of charge. Okay, so we have 3,600 coulomb of charge flow across this light bulb in 2 hours. We finally produce a current of 0.5 ampere. Okay, the next question, B, student. If one electron carries 1.6 times 10 negative coulomb, okay, of charge, calculate the number of electrons which are transferred through the bulb for 2 hours. Okay, how to do B? You are given, this is the charge, 1.6 times 10 negative 19 coulomb. So find the number of electrons transferred through the bulb for 2 hours. Okay. So this is the formula. Q equal NE. Q we have calculated earlier in the first part, 3,600, the charges. So we are looking for N. E is the number of charge. Okay. So you do the substitution, find N. So N will be 2.25 times 10 power of 22. Okay, so I hope you are clear with question 3A and 3B. Alright, okay, now let us try number 4, student. Now we have electric charge flow through a light bulb at this rate, 20 coulomb for every 50 seconds. It says 20 coulomb charges pass through for every 50 seconds. So now find the electric current show on the ammeter. What is ammeter? Ammeter is a device used to measure electric current. Alright? Okay. So how to find current here? So this is a very direct question. Okay, what is the current? So current is Q divide T. Charge divide time. So the charge is 20. So the time 50 seconds, which means the ammeter will show reading 0.5 ampere. I mean there are 0.5 ampere of current flows across the bulb. Alright? Okay, next, number 5. Can you do number 5? Okay. Now there are lightning strikes between two charged clouds and produce electric current of 400 ampere which flow for 0.05 second. So the question is, what is the quantity of charge transfer? So here we are looking for Q. They give you I, they give you T. So to find okay, now question 6 onwards relates to potential difference. Question 1 to 5 relate to current. So 6 and onwards relate to potential difference. Okay, first, simple, the basic. What is meant by 1 volt, student? Apa maksud 1 volt? What is meant by 1 volt? Okay, if you understand the definition for potential difference, 1 volt means 1 joule of energy is required or 1 joule of work is done to move 1 coulomb of charge between 2 points in an electric field. Okay, so this is 1 volt means we need 1 joule of energy or 1 joule of work is done to move 1 coulomb of charge in between 2 points across a conductor or in an electric field. Right? Okay, number 7. Okay, you are given this information. There is a charge of 5 coulomb. So this is Q equal 5 coulomb. Flows through a wire and the amount of electrical energy converted into heat. So this is the amount of energy required or transferred, 2.5 joule. So calculate the potential difference across the end of the wire. So we are looking for V, potential difference. So how to relate V, charge, and energy. So this is the formula. Voltage is how much work is done in order to move 1 coulomb of charge across 2 points. So you just do the substitution. Okay, the work done or the energy 2.5 joule and the charge 5 coulomb. So answer 0.5 joule per coulomb or 0.5 volt. Okay, simple calculation, right? Okay. Okay, then. Okay, now number 8. Okay, still to do with some calculation. 8 and 9. Okay, we try number 8 first. Okay, we have a light bulb switch on for a period of time. In that period, 5 coulomb of charge. So Q equal to 5 coulomb. Okay, pass through and 25 joule of electrical. So this is E or W, 25 joule. What is the potential difference across the end of the wire? So find V again, student. Cahaya boleh kira nombor 8. So we are given ini 5C, ini Q. Okay. And then 25 joule is W. So we are looking for V, potential difference. Okay. So how to find V? V equal W divide Q. So W is 25 divide 5. So berapa? Okay, so this is the answer. Okay, for number 8. 25 divide 5 is 5 volt. So answer is 5 volt, the potential difference. Okay, now number 9. Okay, number 9, they give you the potential difference. Okay, this is the 2 point across the bulb. Potential difference is 20 volt. And they give you the current. This is current, 3 ampere. So now we must find work done. Find W. So now we are looking for W, work done, in order to transform electrical energy in this period, 50 seconds. So for this question, we will find W, but they don't give us the charge directly. So we need to find charge first. So how we can find charge? Remember, charge also equal to IT, current multiply time. So now you can find the current is 20. So this is voltage, V is 20. The current is 3 ampere. And the time is 50 seconds. So 20 is for voltage, 3 is current, 50 is the time. So answer will be 3000 joule. So the amount of energy transformed, yes, very good, Yaya, 3000 joule. Simple, right? I hope others also can find for question 8 and question 9. Okay? The keyword is just to extract the information and to do the substitution with the correct formula. And don't forget to write your final answer with a correct unit. In physics, unit is so much important. Okay, and answer without unit considered as wrong. So jangan buang maka, jawapan akhir mesti ada unit. Okay, next, let us try to do some structure and short essay question related to current and potential difference. Okay, some of the question is taken from SPM past year question. Okay, okay, now students, you are given the setup as shown in our previous activity. We place a coated ping-pong ball in between 2 plates. R connected to positive terminal, S connected to negative terminal. Okay, first, what is the meaning of electric field? So we have discussed this earlier in 3.1.1. What is electric field? Can someone write the definition for electric field? Apa maksud medan elektrik? So this is the meaning. A region where a charge experience an electric force. Okay, it is a region, an area where a charge experience an electric force. Simple. 1 mark for definition of electric field. Okay, next. Okay, now we have to do some calculation as what we did previously. When the metal coated polystyrene ball oscillate between the two plates for 3 minutes. So the time is 3 minutes. Remember this 3 minutes you have to convert into second. And then we have 0.3 ampere of current. So this is I current. So I 0.3 ampere. T time 3 minutes. Find the total charge transfer between the two plates. So we are looking for charge, which means Q. We are looking for Q. So how to relate Q, I, and T? Charge, current, and time. So what is the formula? Relate these three. Very good. So Q equal IT. Charge equal to current multiply time. Current time must be in second. Okay, so answer 55 coulomb. Okay. Hi there, Desirable. Thank you for joining us. We are now doing exercises for electric current and potential difference. Okay, now we go check on the next question. So you are given this table of 3 different methods, X, Y, and Z. And this is the aspects. The first one is a distance between the two plates. Long for X, medium for Y, and short distance for Z between the positive and negative metal plate. And the mass of the coated polystyrene ball. Medium for X, high for Y, mean big mass, and low for Z, mean small mass. High here mean large mass, low here mean small mass. And the voltage of EHT power supply, low for X, medium for Y, and high for Z. Remember the 3 factors affect the speed of the oscillating ping pong ball just now. What do we need to do with the distance of the metal plate? What we need to do with the size of the ball, and what we need to do with the voltage of the power supply. So which one do you think is the best method? X, Y, or Z? Chaya, which one? X, Y, or Z? Distance between the two plates must be long or must be short distance? So here, student, you can apply the tick to pick method. Tick to pick method. So you can tick first. For distance, we took short distance. Okay, short distance. Okay, so this is the formula. E equal V divide D. E refers to the energy. Okay, energy mean high energy, mean high speed or high frequency of oscillation. So to have higher E, we must have high power supply, high voltage, and also short distance. Plus another one, small mass. Okay, so we understand this from the previous discussion, okay, conducted earlier. So now metal, the mass of metal must be low. So we tick the most suitable characteristic, and the voltage, it must be high. So from here, clearly the best method to apply is method Z, in order to increase the frequency of the oscillating ball in between the two metal plates. So distance short. Why? To increase the speed of oscillation or oscillate faster. Okay. Mass must be low. Why? To increase acceleration or to increase the speed. You can mention about speed but never mention anything about the frequency, because the frequency is in the question. So you can mention about the speed, which can relate to the frequency as well. Okay, and for the BEHT, it must be high magnitude or high voltage. Why? So this is to provide stronger electric field or also to increase the speed of oscillation. So by this, which one is the most better choice? Answer will be Z. So we choose Z. All right. So this is one kind of application question you can apply when you understand the concept on how to increase the speed or frequency of the ball oscillating in between two metal plates. Okay, now students, what happens if the nylon thread in diagram 8.1 now replaced with copper thread? Okay, we change the thread from nylon, change into copper thread. We know that copper is a metal, nylon is a fabric. So what happens if you change a fabric thread with metal thread? Okay, so first, what happened to the ball? It will be stationary. Okay, it will not oscillating anymore. It will be stationary at the center between the two metal plates. Why? Okay, once we replace with the copper thread, which is also a conductor, so what happened? The charge on the ball will be earthed by the copper thread. Or you say no charge on the metal coated ball. It has been neutralized or has been earthed by the copper thread. Okay. Okay, then I think the last question for tonight, question 12 here. Again, we have this setup, but now we have a candle flame, which is placed in between metal plate P and metal plate Q, connecting to this EHT, extra high tension. Extra high tension mean power supply with higher voltage. Normally, we use 4,000 voltage. Why we use high voltage? Because to provide stronger electric field. Then only we can see the effect on the candle flame or the ping pong ball which is placed in between. Alright. Okay. Again, the same question. What is meant by electric field? A region where electric charge, experience, and electric force. Okay. Simple. So if you do for so many times, I believe you can settle down. Okay, you can keep the definition here. Okay, until your SPM day. A region where a charge experience electric force. Okay, next. Okay, can you explain what happened to the candle flame when we switch on the EHT power supply? Apa akan jadi pada lilin cahaya bila kita hidupkan bekalan elektrik? So what happened to the flame? So first and foremost, what will happen? The heat from the flame will ionize the A molecule around it into positive and negative ion. Okay. Second, what will happen to this positive and negative ion? They will be attracted, okay, to the plate. The positive ion will be attracted to the negative plate, while the negative ion will be attracted to the positive plate. Okay. Then what happened? Are they going to be separated symmetrically? So will be no. So the third point, the candle flame spread out in two opposite direction, where the portion spread towards the negative plate is larger or wider or bigger. And why is that so? This is because positive ion or positive charges has greater mass and size compared to negative charges or negative ions. So that's why you will find out bigger portion will spread to the negative plate while smaller portion spread to the positive plates. Alright? Okay. So this will be the last exercises for tonight, I guess. So before we ended the session, I would like to share the link for ECG. Right? Anda boleh isikan, siapa yang ikuti kelas kita daripada awal tadi, anda boleh isikan link sijil ini untuk mendapatkan sijil anda sebagai kenang-kenangan. Sijil dia cantik Cuma beberapa minggu ni cikgu tak sempat generate. So kita akan generate sekali sijil untuk minggu ini. Isikan pautan ini dengan berhati-hati, dengan teliti. Pastikan anda masukkan email yang betul, nama yang betul, nombor IC yang betul. Okay, supaya kita dapat hantar sijil ke alamat email anda. So anda akan terima sijil itu melalui email yang anda isikan dalam link ini. Okay, so students, I guess that's all for tonight, the discussion on 3.1. Effort you put on. Terima kasih banyak-banyak kerana telah mengikuti kelas pada malam ini. Cikgu harap sedikit sebanyak dapat bantu kamu untuk faham topik ini dengan lebih baik. Okay. So, Ciaya, anything you would like to say to our friends out there? Ada apa nak cakap dengan kawan-kawan? Tak dengar suara. Buka mic. Okay. So, I hope you can join us again next week with the next Learn 3.2 Resistant with Mr. Pe Kok Hua. Okay, jangan lupa ikuti lagi siaran kelas fizik tingkatan 5. Minggu depan akan dibawakan oleh Mr. Pe Kok Hua dengan tajuknya 3.2 Resistance. Waktu yang sama hari Ahad pukul 8.45 malam. Dan kita ada kelas untuk tingkatan 4 dalam bahasa Melayu dengan tajuk yang seterusnya 3.1 hukum semester 3.1 3.1 gravity. Okey. So cikgu dah kongsikan pautan sijil. Sekali lagi terima kasih kepada semua yang terus berada, terus follow kelas-kelas kita. Teruskanlah menyokong kami di Akademi Youtuber, terutamanya bagi subjek Fizik SPM. Kita ada 2 slot setiap minggu, Jumaat 9.30 malam untuk kelas tingkatan 4 dan hari Ahad 8.45 malam untuk kelas tingkatan 5. Okay, so cikgu rasa itu saja untuk malam ini. Terima kasih kerana bersama-sama dengan kami. Semoga kita berjumpa lagi dalam siaran yang akan datang. Jadi Assalamualaikum, selamat malam dan terima kasih semua. Bye-bye dan jumpa lagi.